We are done with data importing. We are done with step 2, which is univariate analysis. We took all the categorical variables, which are known as dimensions. We analyzed them. We took all the numerical variables like income, number of loans, monthly utilization. We have analyzed them as well. We took some notes. We have observed some issues. There are some variables that are having outliers. There are some variables that are having null values. We are going to clean them a little later. As of now, based on the need, we will clean them. Let us get into bivariate analysis. Remember, these data visualization tools, when you are learning, don't focus on just learning the features. Knowing the features is only one side of the story. You must know where to use them. So that's why it is always a good idea to understand where these features are used. So let us understand the bivariate analysis. What is bivariate analysis? The X variable versus a target. Our target is whether a customer is risky or not. What we want to do is whether is there any impact of these variables. Number of loans. If the number of loans are more, that means the customer may turn out to be risky. Age. Whatever is the age, does it really impact the risky nature of the customer? Or the monthly utilization, if that is high, does it impact whether customer will turn out to be risky or non-risky? So let us do the bivariate analysis. Let us start with one by one variable. So let us create. Meanwhile, every now and then you can always save this workbook. Make sure that you're saving it every time. Yeah, it already exists. We are simply updating that. Okay. Now let's do the first analysis. I will it's uploading. Uploaded. Now age versus target. You can take the same age variable, this histogram, and then try to create a duplicate out of it, or you can create freshly also, but I would suggest you to create freshly. That will give you some experience, that will give you much more practice. So create a bin, this thing, and if you want to change the bin size, that can also be changed. Looks like it is using our bin size only. Now your target variable is whether the customer is risky or not, default or risky or not. I will keep that on the color. Okay, but risky or not, that is one way. Okay, high risk, low risk, you can check that. This is one way histogram versus this one. So what I'll do is I will also try to put that defaulter on the label as well. Is it? Yeah, these are all ones, these are all defaulters, these are all non-defaulters. So as age is increasing, is it true that defaulters are increasing? Not really. Only in this range these defaulters are increasing. The rest of the ranges are almost same. Or maybe what I'll try to do is I'll try to take a percentage of the count. Quick table calculation, is it there? No, not possible. Quick table calculation is not there for a measure. So this is the data that we have. Or another way to look at it is you can create a box plot and compare two box plots. To consider age and then take a customer ID as a detail, add all members, and then what you do is convert it to a box plot. This is the box plot for all the customers. Now what I'll do is I'll take a default risky or non-risky, put it on columns. If you put it on columns, and to make it a different color, I will also hold this and hold control, put it on color. So these are all the customers who are defaulters, that means bad customers. On an average, looks like their age is lesser. These are all the customers who are defaulters. On an average, their age seems to be somewhat higher, because if defaulters, non-defaulters are almost same, if they are good customers, bad customers, if they behave the same, these two graphs should be identical. But here they are not identical. That means there is some impact. Like when age is high, people who are having age 60, most of them are non-defaulters. Like when low age people, they are defaulters. Default means bad customers. So let me not use the term defaulters for the ease of our discussion. 1 means bad customer. So bad customer seems to have lesser age. Good customers seem to have higher age. That's what we are observing, but a very marginal, minimal difference. That's it. Okay. That is one of the analysis. You can say age versus, you can rename it, or let me delete this. I'm not interested in this. You can rename this as age versus a target. Okay. That is one. Then the next variable that we are trying is monthly credit card utilization. So here is the monthly credit card utilization. Again, the same box plot. Like what we can do is we can reuse the same one, but let us use monthly credit card utilization. Create a box plot. That means customer ID should be on detail. Add all members, and then create a box plot. Taking time, and then get the defaulter or risky as columns. The same one, defaulter or risky in terms of rows or in terms of color. This is all the bad customers. These are all the good customers. But since there are outliers, we cannot make anything out of it. But however, if you do the filtering, then you will be able to make some meaningful adjustment. So what I'll do is I will take monthly utilization, put it as a filter. Monthly credit card utilization, I'll put it here. Next, range of values, then apply. Let me take monthly credit card utilization. Here the filter will be there. Show filter, and then bring it here. Monthly card utilization from 0% to 100%. 100% means 1. 1 means 100%. Now you can see that people who are having higher card utilization, or you can say that if the monthly credit card utilization, the people who are having what is this who are bad customers, their card utilization is distributed like this. People who are good customers, their monthly credit card utilization is distributed like this. Again, there is no clear evidence that whether it has an impact or not, but overall this is trying to tell us the relation. But unless until there is a very big difference between 0 and 1, we will not be able to decide anything clearly. Okay, it looks like there is not much of a huge difference, okay, between this one and this one. When you are unclear what is happening, you can get the actual values from this box plot. If you put it here, you have seen upper whisker, upper hinge, median, lower hinge, lower whisker. So those hinges, they are trying to tell us what are the percentile values. Okay, so here you're getting the median value. 50 percentile is 0.02. So here 50 percentile is almost 0. So if you come here, the upper hinge looks like this is the number. The upper hinge is 0.45. I'm assuming that is the 75th percentile. The 75th percentile is 0.45. The 75th percentile is 0.13. Okay. So you can compare these values when you're comparing, but this is not a very clear evidence. In fact, we have anyway, what we have done is we have taken a filter. Again, there's no clear evidence that monthly credit card utilization has how much of impact on the target variable from this particular graph. Or maybe let us create a histogram overlay kind of thing, whether it will give us an idea or not. Let us see that. So let us take monthly credit card utilization percentage, and let us take customer ID, put it on detail, add all members, and then create a histogram. Let me just get customer ID out, take only one variable, and then put it as a histogram. Now, since there are outliers in this, the histogram is not coming accurately. So what we will do is we will take this monthly credit card utilization, all values next, use it as a filter. Max to max, we would like to use as 1 only, then apply that. Okay. Then I'll go to this monthly utilization credit card bin, change the bin size. Okay, edit it, edit the bin size. Here the size of the bin is 5717 and so on. That is too much. What if you take the size of the bin as 0.1? What happens if the maximum value, is it still considering the maximum value? Let us see. So looks like these are the customers who are having very less utilization. Most of the customers are having lesser utilization, and there are some customers having 40%, 50%, 60% utilization. This is the graph. Now what I'll do is I will take defaulter or risky. I will also change the bin size further. Let us change the bin size further into, edit this. Let us make bin size as 0.05. That means 5% improvement only. Okay. Then take defaulter or risky, put it on a column or color. Yeah, color. Most of the risky customers are here, and then not many here. So there is no clear evidence. So we can ignore that variable as well. Not ignoring, at least we got some information that utilization monthly. Actually, it should have, but utilization versus risk or the target, looks like there is not much of information in the monthly utilization. It may not have impact on the target because these two histograms or these two box plots are not very different. Almost these two are also almost same. Let's go to the next variable, which is late payments count. So here is the late payment count in last 2 years. So what we will do is we'll try to create a table for it. These are the late payment counts. Okay. Now what I'll do is I'll try to convert it into a dimension so that it will be easy for us to analyze. So late payment count in last 2 years, convert it to a discrete or a dimension, and then try to take a defaulter risky. Then I will get all the other values inside this. Now let's take the sum or count. These are the values. Now if you want the percentages as well, then first convert it into quick table calculation, percentage of total. So this is the percentage of the total in that row. What I'll do is again, I will get the customer ID. Again, I'll put it in here on the text. And this time what I'll do is I'll try to make it as count so that I have both the values. But this is not the table that I'm looking for. If you click on the table, this is the actual final table. No, this defaulter risky should be here. Yeah, defaulter risky 0 and 1. This is the percentage. This is the count. You have the percentages as well as the count. Okay. Even the measure name can be adjusted automatically. This measure names is created. Okay. We are not creating it. These are the counts and these are the percentages. So what we're trying to say is if the number of late payments are increasing from 0 to 1 to 2 to 3 to 4 to 5, is the risk also increasing? Risk means percentage of customers who are not paying, are they increasing? Look at this, they are increasing. If nobody, like if a customer has never paid lately, only 4% of them turn out to be bad. A customer who paid at least once lately, 15% turn out to be bad. A customer did not pay 2 times, like 2 times a customer has paid lately, then in that bucket, 26% of the customers turn out to be bad. That means if the number of late payments are increasing, if a customer is making more and more late payments, the bad percentage is increasing. That means this is a very impactful variable. This will have an impact on the target variable for sure. In fact, if you want to make it much more visually appealing, what you can do is you can put this percentage on the color as well. You can modify that color. The color that I like when it is comparison is red, green, gold diverging. That means if the bad and reversed, that means higher values are negative, like higher values are red in color. So higher values are red. Now, if you want to change it to be background, then use this option called square. So 96%, you know, 96, 84. This is the percentage of good. This is the percentage of bad. Look at this, percentage of bad keeps on increasing. The percentage of bad keeps on increasing. That means if a customer is paying late out of 2 years, 6 times, Out of 24 bills, 6 bills, if a customer is paying late, that means in that bucket, half of the customers are turning out to be bad. 56% are bad, which 52% are bad, which is like very, very uh, peculiar scenario. How can you say that like out of 100 people, out of 66 plus 74, out of these many people, nearly 140 people, 74 customers turn out to be bad, they did not pay back. So this is a very good indicator. If a customer is paying late every time, that means there's a high chance that he's a bad customer. Do not give him loan. Here 96, 98 seems to be erroneous values. If it is just 2 years data, max to max 24 bills are generated. How can somebody have 96 and 98? Looks like there is some error there. But as of now, we are not cleaning the data as it is. We are using it. We're trying to interpret whatever are the real values. Or we are trying to filter out the data here itself. So you have this, what is that, late payment count. We will try to use control and put it as a filter. And then use everything except these two. Select all, let's say apply. Okay. And then what we will do is we will show filter, and this time instead of all I will use everything except 96, except 98. These are the ones that I would like to, and I would like to display this as a drop down, multi-value drop down, so that it looks smaller, and select all this. 96, 98 removed. So in conclusion, what I'm trying to say is, if the late payments count is increasing, then the percentage of bad customers are also increasing. That's what I meant to say. Okay. That is the bivariate analysis that we are discussing. Now it's time for us to do a quick exercise on this. You find the relationship between depth ratio, which is a continuous variable, versus target, which is risk. So when you are comparing continuous versus target, you have to do either histogram to histogram overlay or create two box plots. Find the relation between number of dependents versus risk. If there are more and more dependent, does it impact the risk? Again, you may have to convert that number of dependents into a dimension and then create a crosstab. Here you have to create histograms or box plots. So try out these two steps. Then we will go to the next step, which is the multivariate analysis. So before getting into multivariate analysis, make sure that you complete this exercise.